Okay, so one of my students asked me to do an example of long division, so algebraic long division, right, with polynomials that requires you to use a placeholder. So you are required to use a placeholder when you'll realize here, if I arrange this in descending order, which is what we're supposed to do, from the highest degree to the lowest degree, you'll notice that one of the degrees is missing, right? So it jumps from a degree of 2 to a degree of 0. So first, let's write it as normal long division. So I will write it like this. So I will have x minus 5 going into... So now I will write it in decreasing degrees. So I have x to the power of 3 first, minus 14x squared plus 100. So you'll notice over here, a degree is missing. So it goes 3 to 0, right? Because this is actually like x to the power of 0. So we need to put a placeholder because with division, long division, we know that we align things, they get eliminated. So in order for this to go smoothly, we need to put a placeholder. So I put 0x. So no, you don't need to put a value. So it's really like it doesn't exist, right? 0x, but it will make the long division go smoothly. Okay, so this requires a placeholder. Okay, so we can go ahead and do the long division. We ask ourselves, how many times does x go into x cubed? All right, so that is what? X squared. Right, so then we do x squared times x, and then we're going to do again the x squared times the negative 5. So x squared times x is x cubed. X squared times negative 5x is, negative 5 is negative 5x squared. Then we are subtracting, and it's a binomial, so we put the subtraction sign in front of there. I know students are like, oh, my teacher always tells me just to write the opposite. Yes, I get that, but you've got to show where that actually comes from. Why are you writing the opposite? Well, because in long division, we do subtraction, and because this is a binomial, the subtraction sign is going to go in front of here, and it's going to be applied to everything in there. So yes, everything's going to switch signs. So then now this will become positive. So then we have positive 5x squared minus 14x squared, right? So that's going to be, let's write that, negative 9x squared, right? Just like regular long division, we bring that down. We have 0x. Now you ask yourself the same question. How many times does x go into negative 9x squared? Well, that looks like negative 9x. Negative 9x times x, we have negative 9x squared. And then we have negative 9x times negative 5. That is positive 45x. Okay, and then we're going to do the same thing. Subtract. Okay, so we're going to subtract. So then the negative 9x squared becomes positive. And the the positive 45x will now become negative 45x. Then we'll bring down that 100. And then ask ourselves again, how many times does x go into negative 45x? Well, that is negative 45. So we have negative 45x. And then negative 45 times 5. So if you want, we can do it on the side. Right? 5 times 5 is 25. 5 times 4 is 20. So that's 225. So we have plus 225. And then the final step, we're going to do subtraction. And then we have 100 minus 225. So that will be negative 125. So you'll realize here, not only did we have to use a placeholder, you'll also realize that we do have a remainder. So this negative 125 is a remainder. And we don't just say, hey, we have a remainder of negative 125. That's not how we do it. We have to actually include that in our answer, right? So remember, long division is basically a form of, it is a method for factoring, right? So it comes into the factoring chapter. So our final answer is going to look like this. So we are going to write what our answer was. So our answer, let's just make that clear. What is our answer? What is our answer? So our answer is x squared minus 9x minus 45. And we have to actually, let me write my 5 better than that. We have to include the remainder. So how do you write remainders? It is no different from when you're using regular numerical values and it's not algebra. I'm going to take my remainder and put it over my divisor because that's what's left out of my divisor, right? So I'm going to write plus, and then I'm going to write 125 over x minus 5 because that's how much is left out of my divisor after I've asked myself how many times can this go into there, and then what is left is what's left over the divisor.